Okay, before we start the new lesson for today, I would like you guys to take a look at the following question. It is dealing with empirical rule, which is covering the measure of variability that we talked about in the last lesson. So take a look at this scenario, pause the video here, see if you can answer those 5 questions, and then unpause the video to get the answers. Okay, for number 1, we got 95%. Number 2, 97.35%. Number 3, 16%. Number 4, 12 ounces or less. And number 5, 12.4 ounces or more. If you had trouble with any of those questions, check out the previous video on measures of variability, empirical rule. Today's lesson, we're going to be taking a look at measures of position. So we're going to be looking at 4 measures of position today. The first is what's called a z-score. And then we're also going to be looking at quartiles, deciles, and percentiles. So the first measure of position is a z-score, or a standard score as it's sometimes referred to. And this is a really important formula that we use in statistics quite a bit. So the z-score is calculated by taking the data value minus the mean and dividing it by the standard deviation. So the formula looks like z equals x minus mu over sigma. A z-score represents the number of standard deviations a data value falls above or below the mean. So let's take a look at some examples. The first example says the class average on a particular test is 83% with a standard deviation of 7%. Determine the z-score or standard score of each student listed below, and then interpret each. Okay, so the first person we're going to take a look at is Renee. She scored a 97% on the test. So we're going to convert her test score into a z-score. Using that formula, z equals x minus mu over sigma. Okay, so x is representing her test score, her data value, which is a 97, minus the mean, which is 83, and divided by the standard deviation, which is 7. So if we subtract 97 minus 83, we get a difference of 14. Divide that by 7, we get a z-score of 2. If we think about what that means, let's say that these test scores are normally distributed. We don't know that they are, but let's assume that they are. The mean is 83. Which would fall right there in the middle. Now, to get to Renee's z-score, we would have to add 2 standard deviations in the positive direction. So we would add that 7% twice in order to get to Renee's z-score of 2. Okay, let's do the same thing for Kenny. Let's find his z-score. So his data value is 74 minus the mean of 83 and divided by the standard deviation of 7. So if we calculate his z-score, 74 minus 83 gives us a difference of negative 9. He's below the mean. And if we divide that by 7, we see his z-score is negative 1.2. I'm going to round that to 9. Typically, we do round z-scores to the second decimal place. So he is 1.29 standard deviations below the mean. So he's not to the 2 standard deviations below the mean mark. He's about 1 and a little over a quarter of a standard deviation below the mean. Okay, so he didn't do as well on the test as what Renee did. Pause the video here, see if you can find Brad and Naomi's z-scores. Okay, Brad's z-score is actually 0. So he scored exactly equal to the mean. So Brad is falling right here in the middle of the distribution at the mean value, a z-value of 0. Naomi had a z-score of 0.43. So she's above the mean, but she's not to one standard deviation above the mean. She's a little less than a half of a standard deviation above the mean. So she would be like right there on our distribution, that purple line. Okay, a lot of times with z-scores, you are going to be asked to pick out the data value, the z-score, that is in the better relative position. So if we're talking about test scores, the better relative position is the higher test score and therefore the largest z-value. So for this particular example, Renee has the largest z-score. Her z-score was 2. She was 2 standard deviations above the mean. So she did better relative to the rest of her class. She's higher above the mean. Since we're talking about z-scores for tests, obviously you want to do well on a test. So the higher in the positive direction the test score is, the better. If we're talking about golf scores and we had a distribution of golf scores and we wanted the better relative position, we would actually want to go in the negative direction, since the lower the golf score, the better. So we would want to be furthest from the mean in the negative direction. So just be careful if you're asked to find the better relative position that you understand what the distribution is representing. Okay, let's take a look at another example. This example says the average height of adult women is 64.5 inches with a standard deviation of 2.5 inches. For each woman's z-score, or find each woman's z-score, standard score, listed below. Okay, our first person is Eva, and we're going to find her z-score. So her data value, her height, is 62 minus the mean of 64.5 and divided by the standard deviation of 2.5. If we do that math, we get negative 2.5 divided by 2.5. She has a z-score of negative 1. So in the distribution, if it's normally distributed, she would be 1 standard deviation below the mean. Taylor, if we find her z-score, her data value is 67 minus 64.5, which is the mean, and divided by the standard deviation of 2.5. We get positive 2.5 divided by 2.5. She is at a z-score of 1, so she is 1 standard deviation above the mean. Okay, pause the video here, see if you can find Samantha and Michelle's z-scores. Okay, Samantha's z-score came out to 4.2. Whoa, she is 4 over 4 standard deviations above the mean. So she is way out there in that right tail region. She is really tall in comparison to the rest of women. Michelle's z-score is 0, so she is right at the center of the distribution, right at the mean. She has a z-value of 0. The other measures of position that we're going to briefly be talking about are quartiles, deciles, and percentiles. And we can see the definitions of those 3 words listed there. These definitions are easy to remember if you remember those prefixes, quart, deci, and the word percent. All right, so if we take a look at how we convert from one to the other, our first example is we're going to take the first quartile and convert it to a percentile. So what we're going to do this is we're just going to think proportions. So if I think about the definition of quartile, that's 1 out of 4 groups. And I'm just going to make a proportion with X over percentile is 100 groups. So if we solve that for X any way that you'd like, we get the 25th percentile. Again, you can cross multiply to get that. You could just multiply the 4 by 25, and then therefore we'd have to multiply the top by 25. However you prefer to solve proportions. All right, example 2, we're converting the 7th decile. That's 7 out of decile means 10 groups. And again, we're converting that to a percentile. So that would convert to the 70th percentile if we solve that for X. Again, we can multiply the top and the bottom by 10 in order to solve that. All right, and the last example in that top half is the median. If we think about what the median means, this means the middle. It cuts the data into half. So 50% on the left, 50% on the right. So it's the 50th percentile. The 50th percentile corresponds to a particular decile. Decile means 10. And a particular quartile. Quartile means 4. So we're going to solve that for both X and Y. Notice that 50 is just half of 100, so what's half of 10? That's 5. And what's half of 4? That's 2. Okay, so the median is equivalent to the 50th percentile, the 5th decile, and the 2nd quartile. Okay, pause the video here and see if you can find the answers to numbers 4, 5, and 6. Okay, the first example, the 3rd quartile is 3 out of 4. That corresponds to 75 out of 100, so the 75th percentile. Decile 2, 2 out of 10, corresponds to 20 over 100, so the 20th percentile. And then thinking about the maximum value, that is the highest value in a data set. So the largest percentile would be 100, the largest decile would be the 10th decile, and the largest quartile would be the 4th quartile. All right, the last thing that we're going to be doing is reading Ogive graphs. This is a great graph to be able to find those percentiles, deciles, and quartiles just because of the way the graph is constructed. If we take a look, it has weight on the horizontal axis down here. And then on the vertical axis, it has the percentiles. So on the vertical axis, we're looking at the percentiles there. Okay, so we're going to take a look at finding the 30th percentile. We would just find 30 on the vertical axis. And we want to figure out what weight is associated with that. So we're just going to go straight across horizontally and then drop it straight down. And it looks like 120.5 is the weight that is associated with the 30th percentile. So 120.5. Okay, decile 6. Now, this vertical axis is percentile, so we have to convert this decile to a percentile. So the 6th decile, 6 out of 10, is going to correspond to the 60th percentile. So again, I'm going to horizontally see where it meets the graph and then drop it straight down. Looks like it's closer to the 130.5 mark. So I'm going to say that's about 128. Now, with reading this graph, we're going to have to estimate some of those values, but as long as we're close. Okay, Q3, quartile 3. Again, we have to convert that to a percentile first. So if we think 3 out of 4, that's going to correspond to the 75th percentile. So it's about right there, halfway between those two marks. All right, we're going to go again straight across. and then drop it straight down. That looks like it's corresponding to about 130.5. The next question is asking us for the median. The median in terms of a percentile would be the 50th percentile. So again, if I go straight across and straight down from that mark, it looks like it's right in the middle between those two, 120.5 and 130.5. So I'm going to estimate that that is at 125.5. These last two questions are going to ask us to reverse the process. So it's going to give me the weight. It's asking me for a particular decile or quartile. So 140.5, if I find that on the horizontal axis, that's a weight. So 140.5 is here. I'm going to go straight up and then straight across. That looks like it's at about the 90th percentile, but it asks me what decile it is. So I'm going to have to convert that. So percentile 90, that means 90 over 100, and that would convert to what over 10? So 90 over 100 is equivalent to the 9th decile. And then the last question, a weight of 116. So if I find that, I'm going to say that's approximately here. Again, go straight up and straight over. That looks like it's the 25th percentile. The 25th percentile would correspond to what over 4? So 25 over 100 is equivalent to 1 over 4. So it's the first quartile. Okay, the last example for today's lesson is asking you to try one of those Ogive graphs. So this is a graph that's displaying time in minutes on the horizontal axis and then cumulative relative frequency on the vertical axis. So in order to convert these to percentiles, we would just move the decimal 2 spots. So 0.2 is corresponding to the 20th percentile, 0.6 is the 60th percentile, 80th percentile, so on and so forth. So pause the video here, see if you can find the answers to those 6 questions. Okay, for those answers, for number 1, 25.9, again, I went straight across from this 0.8 and then straight down to find that. D4 is equivalent to the 40th percentile. So straight across from this 0.4, I estimated that to be about 23 minutes. Q2, we would go straight across from the 50th percentile. Oh, and I think I underestimated that. The 50th percentile looks like at about maybe 24 minutes rather. Let me change that real quick. I think I looked across from the first quartile when I did that initially. Sorry about that. So it looks like maybe 24 minutes. Number 4, the maximum commute time. That's the largest. So at the percentile 100, and drop that straight down. It looks like that's 31.9. The decile that is equivalent to the 17.9 minute commute time, I said that that was decile 1. It looks like it's at about the 10th percentile. And then what percentile is the 19.9 commute time? And that is the 20th percentile. All right, this concludes today's lesson on measures of position.